One of the conics we're going to explore are ellipses. And we're going to see ellipses that look into a form such as x squared plus 9 over y squared plus 4 equals 1. And so we want to look at that and recognize, well, which kind of a conic is it? Are we able to recognize that it's an ellipse? And if so, what does that ellipse look like? So before we do that, let's back up a little bit and just give you a quick overview or a brief overview on some characteristics of an ellipse. Ellipses come in generally two standard forms that we're going to focus on. One is one where it's aligned along the x-axis horizontally, or one in the vertical axis. Of course, you can have ellipses skewed off of those, but for our purposes right now, we're going to focus on these two types of ellipses and see how do their equations differ. Notice that we have two equations, and what's the difference between these two equations? Did you notice that this first one has an x squared over an a squared? Plus y squared over b squared? Notice the a and the b. Where are they at on this one? The x squared is ratioed with the b squared, and the y squared is with the a squared. So when you see that difference, if you know that the a squared is paired with the x squared, we have a line flat, a horizontal ellipse. And if it's the other way around, we have one that's in a vertical ellipse. Now, what really is an ellipse? Well, an ellipse is basically a circle that rather than has one center point, it kind of has two center points, or what we call their foci, or their focus points. And what that means that any point along the circumference or the radius of the ellipse is always going to have the same distance at any point. What I mean by that, if I connected a string to maybe this point and touched the boundary there, and then connected it to right there, that combined distance will always be the same no matter where at on the circle I go to. So if I went to maybe this point over here, and I just stretched a string over there, so now the string falls around here, that's the same distance. If I have a point right here and connect that string, the string is the same length at that point as it is at that point as at that point. It's almost like I have strings nailed to those 2 points, and I'm just pulling the string up with my pencil and just drawing all the way around it as I can. And that shape will produce an ellipse. So we have those types of characteristics as we explore the ellipses. What we know then is that in a horizontal ellipse, the A represents the points on the major axis, because it's where the bulk of the ellipse is at. The up and down axis in this case is called the minor axis. The values of the endpoints are related to our A's and our B's. And the focus, where those are at, the two foci, they're represented by this equation, c squared equals a squared minus b squared. Now the derivation of all of these takes a little bit more space than I have time here to do. So right now I want you to be comfortable that these are some of the important equations that we'll come up with as we try to solve some of these particular types of ellipses and work with them. So we have this equation up here. We recognize it in the form of an ellipse. A in this particular case is if this bottom number on the x squared is an a squared, a would equal 3, and b, if b squared is a 4, b would be a 2. And then what would c equal? C equals a squared minus b squared. So 9 minus a 4, and that equals, that's what c squared equals 9 minus 4 equals 5, and c would equal the square root of 5. So there's all the significant points that we need to have in order to be able to graph this particular ellipse. So is this a squished ellipse? I mean, does it elongate along the x-axis, or does it elongate along the y-axis? Well, notice that my larger value is along my x-axis, so that means it's a horizontal one. So we're to graph it then. And it looks like it's going to go out to the distance of 3 is the highest. So I'll go 1, 2, 3, 4. Always one more for bonus. And then as we start to graph it, I know that we have maximum value at A in the opposite direction at A in the positive direction, which is 3. My minor axis, which is the B value, the smaller value, is up at 2 and down at 2. And then there's my shape of my ellipse. It follows through those particular points. So I'll try to draw a nice ellipse as best as I can. And then our focus points. Our two foci are at root 5. Root 5 is between 2 and 3. So somewhere around there maybe. And there we have that particular ellipse. And then it'd probably be good too to go ahead and label those points just so you know and I know and everybody else knows that we know what we're talking about. So this particular point, the end point on the major axis is at the point 3 and 0. Over here, this point is at the point -3 and 0. This point down here, I go over 0 and down 2. The upper point on the minor axis is the point 0 and 2. And the two focus points, this one right here is at root 5, 0. And this one over here is at minus root 5 and 0. So there we have it. We were able to graph an ellipse that's written in standard form. Standard form means that it's equaling to 1. And we understood if it's a horizontal ellipse or a vertical ellipse. We were able to find out what its endpoints were, both on the major axis and on the minor axis. And we also described where the focus points were at as well. Now you may not recognize it, but 25x squared plus 16y squared equals 400. That is an equation for an ellipse, but it's not an equation of an ellipse in standard form. For it to be in standard form, it needs to equal 1. So to do that, what we're going to first do is let's work this out where we have it equaling to 1. So we're going to divide both sides by, you're right, 400. 400 divided by 400, it's a clever version of 1. Then from here, I have two fractions going on. So 25x squared divided by 400 is x squared over 16. And then 16 divided by 400 is the y squared over 25. So dividing by 400 allowed me to set the equation equal to 1. And now I see the equation of an ellipse written in standard form. So is this an ellipse that's elongated along the x-axis or along the y-axis? Or another way is, well, which one is the major axis? Is the major axis the x or the y? Well, it depends on where's the larger value at. The larger value is underneath that y squared, so I know I'm going to have an ellipse that's elongated along the y-axis, or another way to say it, the y-axis is the major axis. So A, in this particular case, is the 25 value, the a squared. So A would equal 5, B equals 4, and then C squared equals a squared. 25 minus b squared, which is a 16. C squared equals 9. C equals 3. So we have all the information that we should need to be able to go ahead and graph and identify what this ellipse looks like. Remember, we said its major axis is the y-axis. And its highest values in A is 5. 1, 2, 3, 4, 5. 5. We have some key points now. So I know along the major axis, my first point is at the 0 and 5. The other endpoint is the point that's 0 and -5. On the minor axis, which is identified by my lower value, my B, which is at a 4. So over 4 and 0, and backwards -4 and 0. So there's my endpoints on my minor axis, and then my focus are at the points at 3. So it'd be 0 and 3 and 0 and -3. So if I were building an ellipse based on those two focus, the ellipse would follow along, and my scale looks a little off, doesn't it? And that's one thing we have to be careful about. When we're developing things with especially ellipses, we want to make sure that our scale is right. My 5 tick marks looks like it matches my 4 tick marks there, so it looks more circular in nature. But if I did do a scale correctly, or a little bit correctly, 1, 2, all right, maybe that one gives me a little bit more of an idea of that. Oh, that's probably a good reminder why it's so important to understand our scale, especially if you're looking at this on a black box and you're looking at if our window is off or in some type of way, that could skew what we're actually seeing. All right, you guys feeling all right as we start to explore this one particular conic section, which is an ellipse?